Hello everyone. Without any long introduction, in this presentation, I will discuss about binomial distribution, its assumptions and applications with the help of two solved examples. We know that binomial distribution in probability theory is the discrete probability distribution that is applicable to the events with only two possible outcomes in an experiment. The two possible outcomes can be either success or failure. As the name itself suggests, bi denotes two or twice, which is the prefix in binomial distribution. Binomial experiments can be used to determine outcomes such as the outcome of a coin toss, the outcome of a test, which can be either pass or fail, a candidate's response to an interview question, which can be either yes or no, and so on. Given a success probability of p for each trial in the experiment, the binomial distribution represents the likelihood for x successes in an experiment for n independent trials. This distribution is used when we have a binomial random variable. The probability of x successes out of n independent trials in a binomial distribution is given by Px equal to ncx p to the power x q to the power n minus x. Here the term independent means that the result of one trial does not affect the result of another trial. The term ncx stands for factorial n upon factorial x into factorial n minus x, which you are aware of. The term p is the probability of success in a trial, while q is probability of failure in a trial, which will be equal to 1 minus p, as the sum of p and q, that is probability of success and probability of failure, is always equal to 1 in a binomial distribution. To learn about the application part of the binomial theorem or binomial expansion, we will see an example here. The example is, you can see this problem, you can go through this problem. 10 coins are tossed simultaneously. What is the probability of getting first part 4 heads, second part at least 3 heads, and third part maximum 4 heads? In solution part, we will first go through the first part. When 10 coins are tossed simultaneously, what is the probability that we will get 4 heads? To apply binomial distribution, we first calculate the probability of success in each trial. Here, in case of this coin, the probability of getting head in each trial is 1 by 2. Therefore, P will be 1 by 2. While the probability of failure in each trial, that is probability of not getting head in each trial, Q is equal to 1 by 2. And the number of trials are 10, means 10 coins are tossed simultaneously. The number of desired successes, that is x, equal to 4. So based on this data, we will apply binomial distribution Px equal to ncx p to the power x q to the power n minus x. If we apply this relation, we get p x equal to 4 is 10c4, 1 by 2 to the power 4, 1 by 2 to the power 10 minus 4. After solving this relation, you will get probability of getting 4 heads is 0.20. That is 20% chances are there that when 10 coins are tossed simultaneously, we can get 4 heads. Now we will go through the second part of the problem, that is probability of getting at least 3 heads. By applying binomial distribution, by applying that relation, the probability of getting at least 3 heads, Px equal to greater than 3, will be the sum of probability of getting 3 heads, 4 heads, 5 heads, 6 heads, and so on up to 10 heads. So here this calculation will be lengthy. So we have an alternate approach also, in which we can write that probability of getting at least 3 heads will be equal to 1 minus probability of getting 0 heads plus probability of getting 1 head plus probability of getting 2 heads. And for this, we will calculate probability of getting 0 head first. By applying binomial distribution, it will be 10C0, 1 by 2 to the power 0, 1 by 2 to the power 10 minus 0, which comes as this much. Similarly, we will calculate probability of getting 1 head. It will be 10C1, 1 by 2 to the power 1, 1 by 2 to the power 10 minus 1. And this will be 0.0097656. We can also calculate probability of getting 2 heads, which will be 0.04394. To calculate the probability of getting at least 3 heads, we will use this relation and put the values of P0, P1, P2 in it. And we will get probability of getting at least 3 heads as 1 minus probability of getting 0 head plus probability of getting 1 head plus probability of getting 2 heads. And it will be 0.9453. Now we will go through the third and last part of the problem, that is probability of getting maximum 2 heads. The probability of getting maximum 2 heads will be equal to sum of the probabilities of getting 0 head, probability of getting 1 head, and probability of getting 2 heads. And by applying binomial distribution, we can calculate the probability of getting 0 head, probability of getting 1 head, probability of getting 2 head. As we have calculated these values in the previous part, we will put these values in this part directly. And we will get the probability of getting maximum 2 heads as 0.0546815. Here we will go through one more problem, one more example for the application part of the binomial distribution. Here you can go through the problem. The average percentage of failure in a certain examination is 40%. What is the probability that out of a group of 6 students, at least 4 will pass the examination? Means from a group of 6 students of this population, 4 will pass the examination. So here we can go for solution part. As the average percentage of failure is 40%, the probability of failure in a trial is 40%. That is Q equal to 40 by 100. That is 0.4. Similarly, the probability of success E will be equal to 1 minus 0.4, that is 0.6, as E plus Q is equal to 1. The probability that at least 4 students pass the examination will be given by Px equal to greater than 4, P4 plus P5 plus P6. Here you can calculate the probability P4, P5 and P6 by applying binomial relation. And this comes to be 0.544320.